for every element, any element or every element, every element. This is much better. Every element B can be expressed by B equal to X over A, where n belongs to integers. So if this happens, then we can say that D can be written in this way, as that n belongs to positive integers. So, or you can write here E is the generator of the group G. So for multiplication, actually, this is this form is written. Here star is showing that multiplication. It happens that we have a addition. If such kind of cases happen for binary combination multiplication, and every element can be expressed as by the element A taking the power, taking the integer power of A. Every element can be expressed by A. Then A is the generator of G, and G is for cyclic group. G is for cyclic group. For addition, we can take there exists an element A. Element A belongs to G, such that every element in G every element in G can be expressed by in this way. And a finite number of times with using addition composition, a finite number of sum of A will give us the other elements of the G. So G is integer. So here also G can be written in this way. So that A belongs to integers. If such kind of case happens, that binary combination addition with respect to binary combination addition, any group, added group, uh, uh, for any element, the other elements can be expressed by it, uh, taking a finite number of addition of the element, and the then the element for whom the other element can be generated. This is called generator. And if it can be expressed in this way, any finite group, then we say that this is a cyclic group. So G is a cyclic group. Finite is not necessarily, but infinite group can be also can be expressed. So if any group under addition or under multiplication can be expressed by a generator, um, uh, every element can be expressed by the generator. then we call that G is a cyclic group. I am giving an example. Example, set of integers under addition is a cyclic group. How is a cyclic group? How we can prove this? Actually, for any element, it can be expressed uh, by a generator. Z actually is that minus 3, minus 3, minus 2, minus 1, 0, 1, 2, and dot dot. This is the set of integers. Now, if we take the generator 1, if we take the generator 1, generator is 1, then generator 1 can generate other elements. Like if we wish to generate 2, then 2 can be uh, generated by 1 plus 1 under addition. So just 2 times of E1 can generate the element 2. So in this way minus 2 can be generated. We'll take minus 2 multiply 1 in there is there will get minus 2. Actually the n belongs to set of integers. So n can be negative or positive. So through the generator we can generate any element, any positive element or any negative element. So 1 is the generator and it is a cyclic group. In this way we can prove under addition. So if we'll take minus 1, then also it can be generated. So 0 is can generated very easily. We can take n is equal to 0, then we can easily generate 0. Minus 1 also is very is also a generator. We can very easily generate minus 1. And if we wish to take we wish to find out 2 or generate 2, then we can take minus 2 multiply minus 1. Then minus 1 is also the generator. We will get 2. Minus 2 belongs to set of integers. So in this way, we can prove that Z have two generators, 1 and minus 1, and Z under addition is cyclic group. Another example, if we if I give a very good example, I think a finite group is this. That was a infinite group. This is finite group 1 minus 1 iota and minus iota. is a finite group. There are four elements. So under multiplication, A is a uh, cyclic group. How? What is the generator? Here is the generator is iota. Iota is the generator. How? If we wish to generate 1, then we will take I, I, minus 1, I. So here the power is I to the power 4. So here n is equal to 4. So 1 can be generated by I. Minus 1 also can be generated. This is just we have to do I square. 2 is the index here. 2 and you can generate. I can be generated very easily, just taking power 1, and minus I can be generated if we take I cube. If we take I cube, then n is equal to 3 and minus 1 can be generated. Also, if we take minus I, then also we can get other elements. I is also a generator, minus I also is a generator. How? 1 can be generated very easily. There is minus, we take just I square minus I square. 4 we have to take, cannot be. Then we can generate 1. Minus 1 can be generated, just taking minus I whole square, and minus I can be generated by itself taking power 1, and I can be generated by taking minus I cube. So here interesting thing is that there are two generators, iota minus iota and plus iota. So both can generate this finite group. So that's why this is under multiplication is a cyclic group. An interesting thing that the indexes are n are taking just four values, 1, 2, 3, and 4. These four values taking and can generate this finite group. So it is not necessary, n can be anything, n belongs to set of integers, so can be anything. I hope this example much clear to all of you what is a cyclic group, and the previous example was infinite group. That was also very good example. So I hope you like the video. Like, subscribe to get such kind of videos. Like, subscribe, comment me, share with your friends. Like, thanks for watching. If you any suggestion, then comment me.